Okay, now we'll start looking at the chain rule. And sometimes the chain rule is obvious, sometimes it's not so obvious. But we'll start with A. So what we have to do is we have to find the derivative of f of 3x. Now, you might be tempted to try and take out the 3, but don't do that. Okay, instead, what we're going to do is we're going to think of, as we look at this, the outside function is f. So f becomes our outside function, and I want you to start thinking of 3x as a function. We're probably not used to doing it, but it's 3 times x, so we're manipulating x, and that means it's a function. Okay, so the 3x is the inside function. Now if we think about it like this, then we have a chain rule problem to deal with. So remember how the chain rule goes. The chain rule, in its sort of most oblique and least concrete form, is that to differentiate the outside, we differentiate the outside while keeping the inside the same. So the outside function is f, so differentiate f and you get f prime, but keep the inside function the same. So it's f prime of 3x times the derivative of the inside function. Well, the derivative of the inside function is 3x. The derivative of 3x is 3. So that's what it's going to be. That's what the derivative is going to be. F of 3x. The derivative of f of 3x is going to be equal to f prime of 3x times 3. We want to do this when x is equal to 1. Okay? So if x is equal to, if x is equal to 1, then we have f prime of 3 times 1 times 3. So that would be f prime of 3. 3 times 1 is 3 times 3. F prime of 3 is 1/2. So it would be 1/2 times 3, and that's coming from the question. 1/2 times 3 is 3 over 2. Okay, so there's that first part of it done. Alright, that's the first part of it done. So we're looking for inside functions and outside functions. Right, let's look at B, which is the derivative of 3fx. So we want the derivative of 3 times f of x. Now, it's probably better not to think of this one as a composition of functions, or as an inside function and an outside function. Really here what you're using is you're using one of the earlier rules. You're getting the derivative of a constant times a function. And if you remember what that was, it's not actually, we didn't actually think of it as a chain rule. Basically, what we do is that's the same as 3 times the constant times f prime of x. Okay, so that's all this comes down to. Okay, so if we're multiplying outside by a constant, we just keep that constant. If we're multiplying in part A, if we're multiplying the x rather than the outside function, then it's a different story. Then the chain rule very much comes into it. But in this case, where the 3 is not in the parentheses, we're not doing f of 3, we're doing 3 of f, then it's a different story. So it's a much easier story this way. So again, if x is equal to 1, this becomes 3 times f prime of 1. And if you look back up here, f prime of 1 was equal to 5. F prime of 1 was equal to 5. So this is 3 times 5. So this is 15. Okay. Now let's move on to C. Okay, so moving on to C, and let's go back up to see what C was. It was the square root of f of x. Okay, so we want to get the square root of f of x. Okay. So we want to differentiate that. We want to differentiate the square root of f of x. Well, I guess you could do a couple of different things here. One thing that we normally do with calculus is anytime we have a square root, we replace it with power of 1/2. So this would then become the derivative of f of x to the power of 1/2. Okay, so the derivative of f(x) to the power of 1/2. So this is a chain rule problem again. And the way I would look at this is I would look at the outside function being 1/2, because if you look at how the parentheses are nested, it's 1/2 of f of x, the square root of f of x, the square root's on the outside, f of x is in underneath that. So I would look at that as the outside function being the square root, or the power of 1/2, and the inside function being f. Now don't worry too much if this is difficult for you at the start. Okay, don't worry too much if this is difficult for you at the start. It's going to get easier the more of these you do, but I know that at the start this can be quite confusing. Okay, so if we use the chain rule, remember what it is. The chain rule says it's the derivative of the outside function. So the outside function was the power of 1/2. So we're going to multiply down by the power of 1/2 and reduce the power by 1. So the power was 1/2, we're now reducing the power by 1 is negative 1/2. While the inside stays the same. Okay, so the inside stays the same, the inside function was f of x, so we're going to keep that as f of x. And then the other part of the chain rule says we multiply that by the derivative of the inside function. Okay, well the inside function was f, or f of x, so the derivative of that is f prime of x. Okay, so can we simplify this a little bit? This would become f prime of x, and we've got a 1/2 here, so the 2 goes on the bottom, and f of x to the power of negative 1/2, the negative sends this down below, and the power on it is a half, so that's square root. Okay. Now, again, when x equals 1, at x equals 1, this becomes f prime of 1 over 2 times f of 1. And if we look at what each of these were, f of 1 is negative 3, f prime of 1 is 5. So f of 1 is negative 3, and f prime of 1 is 5. Oh my goodness, this computer is just starting to get a little bit tricky. So we got 5 over 2 times negative 3, but there's a problem there obviously, and that you can't get the square root of negative 3. So here's our issue. Can't get the square root of negative 3, so our conclusion is that the derivative does not exist. Exist when x is equal to 1, and I hope you're enjoying the background vocals here. Okay, so we're making progress slowly, but we have a couple more to do. So we're up to 8.5 minutes, and we only have 10 minutes in this video. So d is important. D, f of the square root of x. So now we want to get the derivative of f of the square root of x. Okay, again, this is another chain rule problem. Okay, another chain rule problem. This time, the one on the inside is the square root of x. So the inside function this time is the square root of x, which is x to the power of 1/2. The outside function is f. Okay. So back to the chain rule. And the chain rule, remember, says that the derivative is going to be the derivative of the outside function, so f prime, keep the inside as it is, so square root of x, by the derivative of the inside function. So we get the derivative of the outside function, keeping the inside function as it is. We multiply by the derivative of the inside function, which will be 1/2 x to the negative 1/2. Or this becomes f prime the square root of x over 2 times the square root of x. Okay, so at x equals 1, we then have f prime of the square root of 1 over 2 times the square root of 1, which is f prime the square root of 1 is 1, 2 times the square root of 1 is 2, and f prime of 1 was 5, so this becomes 5 over 2. Okay, there's one more. So quickly, on to the last one. And let's look at how we would do the last one. This is e, and it's, I think, f of x cubed. Is that what we said? Okay, f of x cubed. So let's try that. We want the derivative of f of x cubed. Okay, this again is a chain rule problem. The outside function is f. It's f. The inside function is going to be x cubed. Okay, so the chain rule says we're going to differentiate the outside, so f prime, keep the inside function the same, x cubed, multiplied by the derivative of the inside function. Well, x cubed is the derivative, was the inside function. The derivative of that will be 3x squared. Okay, when x equals 1, then this becomes f prime of 1 cubed by 3 times 1 squared. Well, that'll be f prime. 1 cubed is 1. 3 times 1 squared. 1 squared is 1 times 3 is 3. F prime of 1 was 5. So this is 5 times 3 is equal to 15. And that's the longest one that we've looked at for a while. There's a lot in it. So break it down, go through it slowly, and hopefully you can follow. Any questions? We'll go through this in class, of course, but any questions you have, just ask. Okay? Thank you.